Now that we saw a plain concrete bar, let's look at a bar with the same cross-sectional dimensions, except for the fact that we have three steel rods. Keep in mind, we're using the same amount of material. We're just removing this much concrete and putting steel in there. Let's see how big of a difference it makes. The numbers again, modulus of elasticity of concrete is 3 into 10 to the 6. The modulus of elasticity of steel is 29 into 10 to the 6. The ratio of the two modulus of elasticity, steel to concrete, is 9.67 and concrete to concrete is 1. The maximum stress that steel can withstand is 20 ksi and the maximum stress that concrete can withstand is 1350 psi again. Now what we do to solve this problem is assume that since steel has such a bigger modulus of elasticity than concrete, that there is no concrete below the neutral axis. It's just these three steel rods. Now seeing the dimensions, we are given that the center of the three steel rods is 2 inches above the base. Therefore this entire length is 14. Let's assume the distance from the top to the neutral axis to be x, so the remainder is 14 minus x. The concept of a neutral axis is that the first moment of the area, that's Q, of steel is equal to the first moment of the area of concrete. Q equals modulus of elasticity times area times the centroid for that area. Equating the two, we substitute the numbers in and we get a quadratic equation in terms of x. On solving it, we find one negative root, which we neglect, and one positive root, which is 5.6325 inches. That is the value of x. Now intuitively, I sub z for the entire cross section should be the I that's contributed by steel plus the I that's contributed by concrete. But to do this, again, we make another assumption. We make an assumption that the area that these three circles represent over here is now represented by a long rectangle of negligible height, just to simplify calculations. Keep in mind that even after factoring these two assumptions in, the actual answer is only 2% higher or lower than the answer that we find. Putting the numbers into I sub z's equation from above, we get I sub z equals 1697.45 inch to the fourth. Using the previous stress equation again, stress for steel this time is equal to moment times centroid for steel times N for steel over I sub z. We are finding the stress for, we this way find the moment that steel can withstand, and we want to do this because we want to find out how much better it is to use concrete with steel instead of just concrete. Making m the subject again and putting the numbers in and solving, we get m is 6.02 into 10 to the 6 pound inch, which is way higher of a number than the previous example.